All right, so section 3.6, it asks us to solve the polynomial inequality, graph the solution set on a number line, so not like a legit graph, not like a XY coordinate system, and express the solution in interval notation. So we have solved quadratic equations, whether it's factoring or the quadratic formula, a lot. So we should be good at this. The only thing that's different is instead of equals, we have an inequality. So we have to graph the inequality on our number line and then use that to write our answer in interval notation. So it's really just putting two things that we already know together into one problem. So example A, we have 3x squared plus 4x is less than or equal to 4. Regardless, whenever we solve quadratic equations, what do we have to do first? Put it in standard form. Good. Set it equal to 0. So we can subtract 4 from both sides. And we get 3x squared plus 4x minus 4 is less than or equal to 0. So now that it's in standard form, which is like ax squared plus bx plus c equals 0, whatever your sign might be. It's set to 0. We can go ahead and try to factor it. Our first step in factoring is GCF. Is there anything that 3x squared plus 4x minus 4 have in common? No, so no GCF. Our A value is 3, B is 4, C is negative 4. So we're looking for two numbers that multiply together to give us A times C, which is negative 12. And the same two numbers to be added together to give us B, which is positive 4. 6 and negative 2. Good, thanks. 6 times negative 2 is negative 12. 6 plus negative 2 is 4. Unfortunately, because A is 3, A is not 1, so we have to factor by grouping here. So we're going to split up our middle B term using the numbers in our blanks. So 3x squared is going to stay the same. Instead of positive 4x, we're going to split it up using the numbers in our blanks. So plus 6x minus 2x, and then negative 4 is going to stay the same, is less than or equal to 0. We now have 4 terms, so I can group the first two, group the last two. Looking at our first two terms, 3x squared plus 6x, GCF, 3x. Taking out that 3x, we're left over with x plus 2. Looking at our next two terms, negative 2x minus 4, GCF. Negative 2. Factoring or dividing out negative 2, we're left over with x plus 2. So we know we did something right, and then setting that to 0. We know we did something right because they are both x plus 2, so that'll be one factor. Taking out those x plus 2's, we're left over with 3x minus 2, so that'll be our other factor. So x plus 2 times 3x minus 2 is less than or equal to 0. Now that we have it in factored form, we can set each factor to 0. So x plus 2 is less than or equal to 0, and 3x minus 2 is less than or equal to 0. Solving for x, I can subtract 2 from both sides, and we get x is less than or equal to negative 2. And then adding 2 to both sides, we get 3x is less than or equal to positive 2. And then we can divide by 3. Whew. X is less than or equal to 2/3. So here's the thing. Because it's these two factors multiplied together, it affects our signs. It affects what's going on here. So, moral of the story, these are our two critical values. Close. So, whenever we draw on our number line from negative to positive infinity, those signs don't matter. We have to test to see which works. The signs are now irrelevant. So plotting on my number line, negative 2 and positive 2/3. Notice that my number line goes from negative to positive infinity, so it goes from least to greatest. So negative 2 is on the left, positive 2/3 is on the right. are negative 2 and positive 2/3 included based off the symbol?
Yes.
Yes, so because they're or equals to, we know those numbers are included, so we know they're going to be brackets or closed circles. So do you see how our critical values breaks our number line into 3 separate pieces? In between negative infinity and negative 2, in between negative 2 and 2/3, and in between 2/3 and infinity. Yeah? So we have to manually test which one of these works. But our calculator can do the hard part, so it's not as bad as it seems. So what's a number, any number, to test in between negative infinity and negative 2? Negative 3. Okay, we'll test negative 3. In between negative 2 and positive 2/3? 1. Okay, so less than 1, so it has to be less than 2/3. 0. And then we can test 1 over here. So in between 2/3 and positive infinity, we can test positive 1. So we just pick numbers, any numbers you want, because any number will work, to test each little section. So the left section, the middle section, and the right section. Are we okay so far? So what we can do, because we're going to use our calculator to help us do the hard work, is we can go to our y equals. We can plug in this equation in standard form, so 3x squared plus 4x minus 4. I'm just going to plug in the expression, 3x squared plus 4x minus 4. And then we can go to our table, so second table. Plugging in negative 3, we get out positive 11. So is positive 11 less than or equal to 0? No. So because that doesn't work, that section of the graph does not work. Plugging in 0. X is 0, we get out negative 4. Is negative 4 less than or equal to 0?
Yes.
Yes, so this middle section works. And then lastly, plugging in positive 1, we get out positive 3. Is positive 3 less than or equal to 0? No, so this last right section does not work. So our final section, our final answer is the section, the interval between negative 2 and positive 2/3, including those endpoints. So writing this in interval notation, because it's closed circles, we have brackets. From left to right, we're going from negative 2 to positive 2/3. Done. So we're graphing it like normal. We're factoring it like normal. The only thing that's different is testing each interval. And we can use our calculator to do that for us, pretty much. So questions for me so far?
So you would just plug it in like on one calculator, then you go second trace.
Second table, or second graph to go to our table.
Okay.
Yeah, so second and then graph to give us here. So from y equals second graph, and I'll bring it to our table. Other questions? And any number that you plug in this interval will work. So say, for example, if you plugged in between 2/3 and infinity 10 or 5 or 7 or 2 or whatever, any of those numbers won't work. So they'll give you the same answer as long as you have numbers in the interval. All right, let's try the next one, example B. We have x squared is less than or equal to 6x minus 6. Let's go ahead and get this in standard form, set equal to 0. So I'm going to move the 6x and the 6 over. So subtract 6x from both sides, add 6 to both sides. So we get x squared minus 6x plus 6 is less than or equal to 0. So now we could try to factor. Is there a GCF? No. So no GCF. Our A value is 1, B is negative 6, C is positive 6. So we're looking for two numbers that multiply together to give us A times C, which is positive 6. And the same two numbers to be added together to give us negative 6, which is B. Will give us negative 9. We multiply together. So you're right. So nothing works, right? So not factorable. So the quadratic formula. So x equals negative b plus or minus the square root, b squared minus 4ac, all over 2 times a. We know that our a value is 1, b is negative 6, c is positive 6. We can take those values and just plug them in. So negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 6 all over 2 times 1. Those two negatives will become positive 6 plus or minus the square root. In my calculator, negative 6 squared minus 4 times 1 times 6, 12, all over 2.
That simplifies 2 square root of 3.
Good. Square root of 12 simplifies as 2 square roots of 3. So 6 plus or minus 2 square roots of 3, all over 2. And then dividing both terms by 2, we get 3 plus or minus a square root of 3. So those are the critical values going on our number line. So on our number line, which goes from negative to positive infinity. So yeah, so it's like I don't even know which one comes first because I don't even know what 3 plus the square root of 3 is and 3 minus the square root of 3. So in our calculator, 3 plus the square root of 3, is about 4.7. 3 minus the square root of 3 is about 1.3. So I know 3 minus the square root of 3 is smaller. So it'll go on the left-hand side of 3 plus the square root of 3. So this is about 1.3, this is about 4.7. So that way I can see which numbers to plug in. Because it says less than or equals to, I know these two critical values are included, so I'm going to show that by using closed circles. Or brackets if you want, either way. I just don't know which way the brackets are going to face, that's why I use closed circles. So last but not least, testing each section. So some number between negative infinity and 1.3. Negative 2? Sure.
Or 1.
Or 1. It doesn't matter. The calculator is going to do it for us. Between 1.3 and 4.7. 3. And then last but not least, from 4.7 to infinity. 5. So we just picked numbers to test each of those 3 sections. So plugging this into our calculator, we have y equals x squared minus 6x plus 6. So plugging it into my y equals, I'm going to go to my table. So second graph, we'll go to my table. Plugging in x equals 1, we get 1 out. So is 1 less than or equal to 0? No, so this doesn't work. So this left section does not work. Testing to see if 3 works. Plugging in x equals 3, we get out negative 3. Yes, thank you. So is negative 3 greater than or equal to 0? Oh, that's what you're saying yes to. Yes. So that middle section does work. Last but not least, testing 5. Plugging in x equals 5, we get 1. No. So 1 is not less than or equal to 0, so that right section does not work. So our answer is from 3 minus square root of 3 to 3 plus square root of 3. Both of them are included, so we're going to use brackets. Remember, whenever you write interval notation, read your graph from left to right. So bracket 3 minus the square root of 3, comma 3 plus the square root of 3 with another bracket. So final answer for part B. Questions, comments, concerns for me? 2 more, right? Yep. 2 more like this. Are you ready? Example C says 16x squared minus 18x plus 1 is less than 0. It's already set in standard form for us, so that's good. One less step we have to do. Is there a GCF? No, so no GCF. Our A value is 16, B is -8, and C is 1. So we're looking for 2 numbers that multiply together to give us 16, which is A times C, and the same 2 numbers to add together to give us -8, which is B. -4, -4? Sure. -4 times -4 is positive 16. -4 plus -4 is -8. Because A is 16, A is not 1, we have to factor by grouping. So we're going to use the numbers in our blanks to split up that middle term of -8x. So 16x squared minus 4x plus 1 is less than 0. There's now 4 terms, so I can group the first 2, group the last 2. Looking at our first 2 terms, 16x squared minus 4x, GCF. 4x, good, thank you. Factoring out that 4x, we're left over with 4x minus 1. Looking at our next 2 terms, we have -4x plus 1. I know I want positive 4x minus 1 to be left over. What should we factor out?
-1.
-1, good. Factoring out that -1, we have positive 4x minus 1 left over is less than 0. We know we did something right because they are both 4x minus 1, so that's coming out as a GCF, as one factor. Taking out 4x minus 1, what's our other factor? 4x minus 1 again is less than 0. So 4x minus 1 times 4x minus 1, so we can write it as 4x minus 1 squared is less than 0. So I can set that factor equal to 0. I only have to set it equal to 0 once because I know it's going to give me the same answer both times. So 4x minus 1 is less than 0. Whenever I add 1 to both sides, divide by 4 to both sides, I'll get 1 is less than 1/4. So that'll be our critical value. So it's only going to be 1 critical value on our number line. Our number line still goes from negative to positive infinity. We're looking at 1/4. Is 1/4 included? No, it's just less than. It's not or equals to, so 1/4 is not included. So we're going to show that using an open circle. So this critical value gives us 2 parts to our graph, from -infinity to 1/4, and then from 1/4 to positive infinity. So we have 2 sections of the graph we're looking to test to see if they work. So testing a number, what do you want to test between -infinity and 1/4? 0. What do you want to test between 1/4 and positive infinity? 1. Sure. Why not? So going to our y equals, we're going to plug in our new equation, which is 16x squared minus 8x plus 1. So plugging that into y equals. Going to our table, we said we're going to test 0. So whenever we plug in 0, out comes 1. So is 1 less than 0 using the sign that's in the problem? No. So that side doesn't work. Testing positive 1. Plugging in positive 1, we're left over with 9. Is 9 less than 0? No. So that doesn't work. So what's our answer?
1/4.
Does 1/4 work? No. So does anything work? No. So no solution. So if 1/4 was a closed circle, our only answer would be 1/4. But because 1/4 didn't work, neither interval worked, so nothing worked. So no solution. How can I help you on question or example C? How could I help you on example C? If not, we have 2 more problems, and then we're done. Oh man, I'm a little too excited. All right, example D is the next one. Oops. So example D said x cubed minus 8x squared minus x plus 8 is greater than or equal to 0. So if you notice, this is already in standard form for us, so that's cool. That's one less step we have to do. So let's go ahead and try to factor this thing. Is there a GCF? Is there anything that x cubed minus 8x squared minus x plus 8 have in common? Nope.
Can't you like group them?
Yeah, okay. So no GCF. So there's 4 terms already, so let's go ahead and factor by grouping. So grouping the first 2, grouping the last 2. I'm getting a little too excited. I just ripped my paper. Whew, calm it down. Okay, so looking at our first 2 terms, x cubed minus 8x squared, GCF. X squared, good, so I can factor out x squared from the first 2 terms. And we're left over with x minus 8. Looking at our second 2 terms of negative x plus 8, GCF, remember we know we want x minus 8 to be left over. Negative 1, good. Factoring out that negative 1, we have x minus 8 left over is greater than or equal to 0. We know we did something right because they both have x minus 8 in common, so that's one factor. What's our other factor? X squared minus 1 is greater than or equal to 0. Exactly, x squared minus 1 could be factored again. It's a difference of perfect squares. So x minus 8, x squared minus 1 factors into x plus 1 times x minus 1 is greater than or equal to 0. So now it's completely factored. So we can set each factor to 0. So x minus 8 is greater than or equal to 0. X plus 1 is greater than or equal to 0. X minus 1 is greater than or equal to 0. Solving each one separately, we get our critical values of x is greater than or equal to 8, x is greater than or equal to negative 1, and x is greater than or equal to positive 1. So we have 3 critical values that are going on our number line. Our number line's still going from negative to positive infinity, so make sure you put them in order. So we have negative 1, positive 1, and positive 8. So if you notice, now this breaks our graph into 1, 2, 3, 4 sections. So we're going to have to test 4 different numbers. Are these critical value points included with a closed or open circle? They're included, so a closed circle. So what number do you want to test between negative infinity and negative 1? Negative 2. Between negative 1 and positive 1? 0. By the way, sometimes you might have to plug in like a fraction or a decimal. If it's like between 1 and 2, you can plug in 1.5. So between 1 and 8, 2. And then between 8 and infinity, 10. So it gave us numbers to test. So thankfully our calculator could help us do all this crazy mess. If not, it would be even worse. So plugging in our equation to y equals, we have x cubed minus 8x squared minus x plus 8. So plugging our equation into y equals, we can now go to our table. We're first testing x equals negative 2. So plugging in negative 2, we get negative 30. Is negative 30 greater than or equal to 0?
Yes.
No.
No. You were just making sure we're paying attention.
I was making sure I was paying attention.
Oh, okay. If you're just checking yourself, good idea. So x is 0, y is 8. So is 8 greater than or equal to 0? Yes, so that section works between negative 1 and positive 1. Testing x equals 2, plugging in 2, we get out negative 18. So is negative 18 greater than or equal to 0?
No.
Nope, so that section does not work. Last but not least, plugging in x equals 10, we get 198. Is 198 greater than or equal to 0? Yes, so that last section does work as well. So the sections that work are our answers. So going from left to right, we're going from -1 to +1, and from 8 towards positive infinity. All of the endpoints are included, so we're going to use brackets. So again, from left to right, bracket -1, comma, +1, closing that bracket. Or we have this other piece. X could be in this piece, or it could be in this piece. So we're going to use our U to unite the two together. Bracket 8 towards positive infinity. For infinities, we always use parentheses. Final answer. So that was the last type of that type of problem we're going to cover. So questions on letter D. Please, please, please.
All we do is just factor in graph.
Yeah, all we do is factor. We've factored till we can't factor anymore, so we're good at that. We've graphed stuff before. We wrote stuff in interval notation. We plugged numbers into graphs. It's all stuff we've done before, just putting it all together. So hopefully this will be a good little break from all the graphing stuff. Thinking about it in a positive manner, because we have to do it anyway, so might as well be positive about it. All right, last one. Example E. Yes, sure, great. Thank you for your enthusiasm. Example E. Use the graph of the polynomial function to solve the inequality. So this time we're doing exactly the same thing. They just give us a graph to kind of look at it visually instead of looking at it algebraically. So the equation is 5x cubed plus 7x squared is greater than or equal to 28x plus 12. So if you notice, they went ahead and put it in standard form of 5x cubed plus 7x squared minus 28x plus 12 and graphed it. So if they moved everything to the left-hand side, it's saying we would subtract 28x and subtract 12. So we would have 5x cubed plus 7x squared minus 28x minus 12 is greater than or equal to 0. Do we agree? Sure, whatever you say. Yes. Okay, so we're trying to see when are these critical values greater than 0. What's another name for these critical values if it's set to 0? Yeah, solutions, right? Solutions, zeros, roots, x-intercepts, all this good stuff. So they already found the x-intercepts for us. So it tells us if we were to solve this bad boy out, we would get x equals, because I don't really care what the sign is. It tells us this number is 1, 2, 3, so -3, 4, 5, 6, 7, yeah. -3. It tells us this point is -2/5. And this point is +2. So it tells us the 3 x-intercepts, the 3 zeros, the 3 solutions, the 3 roots.
So we can unplug.
1 second. I can't do 2 things at once. So the question is, when are these things greater than 0? What's another word for saying greater than 0?
Larger.
Okay, larger. What else is greater than 0?
Bigger.
What I'm hearing you say is positive. Yes, positive. Thank you. All right, so we're trying to see when is this pieces of the graph positive? Question. Did someone have a question? And I said wait, and I didn't.
I know. You're about to.
Oh, okay. So we are trying to find when the equation or when the graph is greater than or equal to 0, which is positive. So let's still do a number line, because that's staying consistent. From negative to positive infinity. We're going from -3 to -2/5 to +2. Are these numbers included?
Yeah.
Yes, they're included because it says greater than or equals. So or equals means they're included. They're going to have closed circles. So without testing each individual interval, we can just look at our graph. In between -infinity and -3, is this piece positive or negative? Negative. So is a negative number greater than or equal to 0?
No.
No, so this section does not work. In between negative 3 and negative 2 fifths, is this piece positive or negative?
Negative.
No,
It's going positive.
positive, so it's going up here. So it's positive. Is a positive number greater than or equal to 0?
Yeah.
Yes, so that section works. From negative 2 fifths to 2, so now we're looking at this piece down here, positive or negative? Negative. So is negative greater than or equal to 0? No, so this piece does not work. Our last piece is from 2 to positive infinity, so from 2 to infinity. So looking at this piece right here, is this piece right here positive or negative? Positive, negative, positive, positive. So is positive greater than or equal to 0? Yes, so this end piece does work. So just like before, we have our number line all filled out. What worked was from negative 3 to negative 2 fifths, and from positive 2 to infinity, including our endpoint, so we're going to use brackets. So our final answer, bracket negative 3, comma, negative 2 fifths with another bracket, or it could be from 2 with a bracket to positive infinity. We always use parentheses for infinities. Final answer. So that is all of 3-6.